f of x is equal to 6x to the 4th minus 5x cubed minus 2x squared minus 8x plus 3. All right. So f of 1/3, you just put in 1/3 in for x, right? So when you do that, you have 6 times 1/3 to the 4th minus 5 times 1/3 cubed minus 2 times 1/3 squared minus 8 times 1/3 plus 3. Now I'm not going to do, we're going to do order of operations, PEMDAS. But when I did that arithmetic, following order of operations, I got 0. You can verify that yourself. Okay. Exponents, then multiplication, then addition and subtraction. Okay. And then you evaluate function at x equals 3/2. Now, if you evaluate f of x at x equals 1/3 and you get something else besides 0, either you or I made a mistake. Okay. F of 3/2, right? To verify that x equals 3/2 is 0, you put 3/2 in for x on the right-hand side. So 6 times 3/2 to the 4th minus 5 times 3/2 cubed minus 2 times 3/2 squared minus 8 times 3/2 plus 3. And when I did that arithmetic, following the order of operations, I got 0. Okay. So once you do the arithmetic, you verify that x equals 1/3 is the 0 of this polynomial function, this 4th-degree polynomial, and x equals 3/2 is the 0 of this polynomial function. Okay? So x minus 1/3 is a factor of this polynomial function, and x minus 3/2 is a factor, right, from the factors there, which we've said, used many times already in this pack. All right. So to find the remaining 2 roots, right, they're going to come from a quadratic, right? If x minus 1/3 and x minus 3/2 are factors, then f of x can be written as x minus 1/3 times x minus 3/2 times some quadratic. We got to find that quadratic. Okay. So the first thing we're going to do is divide this 4th-degree polynomial by x minus 1/3. So let me make a note. X minus 1/3 and x minus 3/2 are factors by the factor theorem. Okay? So the first thing we're going to do is divide this 4th-degree polynomial by x minus 1/3. Since this is a linear factor, we can use synthetic division. What's c in this case? 1/3. It's plus 1/3, not minus 1/3. So we put 1/3 in our box, and then write out the coefficients in descending powers of x. And the coefficients are 6, minus 5, minus 2, minus 8, and 3. So you know the procedure. Bring down the 6, multiply it by 1/3, you get 2. Put 2 in the next column. Add it to -5, you get -3. 1/3 times -3 is -1. Put it in the next column. Add it to -2, you get -3. 1/3 of -3 is -1 again. Add it to -8, you get -9. And 1/3 of -9 is -3. And you box the last number. 3 minus 3 is 0. Remainder is 0. We better get 0 for a remainder, or x minus 1/3 is not a factor, or we made a math error. So the quotient from our synthetic division, right? These are the coefficients of the quotient. 6, so start going from right to left. -9 goes with x to the 0, which is 1. -3 goes with x. This -3 goes with x squared. 6 goes with x cubed. So the quotient from this synthetic division is 6x cubed minus 3x squared minus 3x minus 9. So f of x can be written as the factor x minus 1/3 times that quotient. 6x cubed minus 3x squared minus 3x minus 9. Now because x equals 3/2 is a 0 of our polynomial function, that means if you put in 3/2 in for x inside parentheses here, that better equals 0, right? Because that contains the factor x minus 3/2. Okay? So 6 times 3/2 cubed minus 3 times 3/2 squared minus 3 times 3/2 minus 9 better equal 0, because this third degree polynomial contains the factor x minus 3/2, right? When we factor this third degree polynomial, right, one of the factors is going to be x minus 3/2. So we can divide this third degree polynomial by x minus 3/2. So we put minus 3/2 in the box. Oh, it's not minus 3/2, it's plus 3/2. Sorry, even I get confused. X minus 3/2 is a factor. 3/2 is 0. And what are the coefficients for that third degree polynomial? 6 minus 3 minus 3 minus 9. We're dividing that third degree polynomial by x minus 3/2. And now we did the synthetic division. Bring down the 6. You multiply it by 3/2, you get 9. That goes in the next column. Minus 3 plus 9 is 6. And then 3/2 times 6 again is equal to 9. That goes in the next column. Minus 3 plus 9 is 6. Again, you multiply 6 times 3 halves and get 9. Minus 9 plus 9 is 0. And you box the last number. That's the remainder. Remainder is 0, just like we expected. Okay. So, 666. Everybody's favorite number, right? So, x to the 0 is equal to 1, right? So this first 6 goes with x to the 0, which is 1. The next one goes with x. Next goes with x squared. So the quotient from this synthetic division is 6x squared plus 6x plus 6. So over here, our 4th degree polynomial can be written as x minus 1/3 times x minus 3 halves times 6x squared plus 6x plus 6. Now in this, we're going to set this equal to 0 and solve for x. But is there a common factor in this quadratic? What's the common factor? 6, right? So we're going to write this as x minus 1/3 times x minus 3 halves. And then we factor out the 6. When we pull out the 6, we're left with x squared plus x plus 1. Okay? So everybody see how I pulled out a 6? Because 6 is a common factor of those all 3 terms. Yes, sir?
Does it matter the order in which you divide those 2 steps?
No, it doesn't. Ogden brings up a very good point. Okay, we could have done 3 halves first, and then 1/3. It doesn't matter because they're both x minus 1/3 and x are both factors. Okay. Okay. All right. I just did it that way because that's the order in which the zeros were presented in the problem. So that, I guess that's the reason why I did it in that order. Okay. All right. So we can now set x squared plus x plus 1 equal to 0 and solve for x using the quadratic formula. Okay. So everything a is equal to 1, b is equal to 1, c is equal to 1. Okay. So by the quadratic formula, x is equal to negative b, which is negative 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times a, which is 1, times c, which is 1. All divided by 2 times a, which is 2 times 1. So we have negative 1 plus or minus the square root. Well, when you simplify this, it's just going to be 1 minus 4, which is negative 3. So we have the square root of negative 3 over 2. Well, remember, division does not undo addition and subtraction, does it? So, this is equal to minus 1/2. Actually, I'm going to write it over here. This is equal, x is equal to minus 1/2 plus or minus the square root of negative 3 over 2. But square root of negative 3 is written as what? I times the square root of 3, right? over 2. So the two zeros from this factor, x squared plus x plus 1, are x equals minus 1/2 plus the square root of 3 over 2y, and x equals minus 1/2 minus square root of 3 over 2y are the last two zeros. Okay. Right? The first two are x equals 1/3 and x equals 3/2, and the last two are x equals minus 1/2 plus square root of 3 over 2y, and x equals minus 1/2 minus square root of 3 over 2y. Okay. Well, we got to write out the complete factorization, right? So we got to write this out. This quadratic out is a product of two factors. So f of x is equal to, I might cut in this, well, this, I'm gonna, f of x is equal to, I'm gonna pull this 6 up front, that's our leading coefficient, times x minus 1/3 times x minus 3/2. And now, the factors, right, these are the zeros. So to get the factors, right, I gotta add 1/2 and subtract square root of 3 over 2y to get the factors. So I have x, the first factor, so I have x plus 1/2 minus square root of 3 over 2y. And then second factor, gotta add 1/2 and add square root of 3 over 2y to both sides to get the second factor. X plus 1/2 plus square root of 3 over 2i. This is the complete factorization of our fourth degree polynomial. Okay. Any questions on that? All right, so now you got everything you need to successfully complete the My Math Lab, the WebAssign homework. Okay. Hey, is there anybody who didn't get the 3.3 handout, which we just finished? Come on down if you need a hard copy.
Oh, I'm good.
You're good?
Yeah, I'm good.
Good. All right, so let's move